Hello, everybody, and welcome to our first pre-conference workshop for New Directions East Asia 2021. Today's workshop is entitled Peering into the Black Box, a new approach to measure how well an AI auto-scoring system works, and will be run by Trevor Breakspear and Will Bayliss. Trevor has been working on the implementation of test technologies in the assessment of productive skills for the British Council since 2017. His main focus is on the development of assessment tools and validation systems that align technology and test development. Trevor has an MA in language testing, over 10 years of project management experience within localization and assessment fields, and 18 years of training and teaching experience in ESL and EAP contexts. Will is an experienced teacher, trainer, and examiner who has been involved in the development of machine-rated speaking assessments, training and managing examiners whose ratings train various AI assessment models. His experience in team management, programming, and assessment delivery is underpinned by an MSc in Applied Linguistics from Edinburgh University. Now, before we begin, I would ask you at the very beginning of the workshop, please make sure your microphone and camera are turned off. If you have any questions during the workshop, please just type them into the chat box. The presenters will try and answer many of those questions along the way. This workshop is interactive, so please be ready to participate as much as possible. Finally, if you have any computer problems or connection issues, just say something in the chat box and me and my colleague will try and help out. Okay, I will now hand over to our presenters, Trevor and Will. Please start sharing your screen and begin when you're ready. Good luck.
Thanks very much, Jonathan.
Thanks, Jonathan. First of all, I suppose the first thing to say is, can you see our screens? It's a phrase I use like 20 times a day.
Yeah, so if you can see us and you can hear us, please type Y into the chat, just so we know that we're broadcasting loud and clear. Fantastic.
Thanks, Ricky. Okay, and obviously, thank you so much for taking the time to join us today in what is the first session of New Directions 2021. Today, we're really trying to show and illustrate a new way of assessing whether an auto-rated solution is fit for purpose, looking at the sort of questions that, as users of a test that aren't necessarily PhD qualified in data science, can actually ask pertinent questions that will help them make a decision on whether to use solution A or solution B. And in the process of doing so, we'll be looking at some real data, suggesting examples of bias and the implications of that as well. And so in order to do that, as Jonathan kindly said, please do get involved. There's plenty of opportunities for interaction, questions in the chat box. We'll try to get through them. We'll be monitoring that chat box as we go. Okay, so we're not going to bother with this because Jonathan did it.
Yes, Jonathan gave us a very good introduction.
Yeah, much better than we could. Right, so usually we do this at the end, but today we're going to ask you to complete this form. The reason for this is we're going to be using your data to illustrate some of the pertinent points in terms of this validation framework. We do need your data. So I know we've got a fairly small sample set, but I'd like Jonathan, please, and Neil, if you've got time, do join in as well with this. The more data, the merrier. And we're going to be sharing the results of your data and the implications of your data as a training set shortly. So if we can give you maybe, what, 1 or 2 minutes?
Yeah. So if you have your mobile phone, please scan the QR code. If not, if you look in the chat, I have put the link in the chat. Please click that and it should take you 1 or 2 minutes to quickly fill out the form. Just to say that we're only going to use your data for what we're doing today, and then the data will be destroyed.
And it's anonymous, so there's no names or anything like that.
Yeah.
Yeah. Thank you.
So yeah, we'll give you, let's say 2 minutes.
Yeah.
Yeah, brilliant. Thanks, Jess. Thanks, Bushra. Yeah, fantastic.
May I know why French? Yeah, we'll tell you about that later. Yeah.
Yeah, we have 8 so far. That's fantastic. Yeah, Alice, it's definitely French. Yeah, definitely French.
And don't worry, this isn't, if you're no more than a beginner, we won't be holding it against you.
Brilliant. That's 11. Yeah, bonjour, Alice. Ça va?
Okay, we've got an A1 at least there.
Yeah,
that's good.
Yeah, still 11. Right. Let's move on to the next slide then.
Okay, please continue to complete this data. The more data we get, the more interesting the following activities will be. So please do keep completing. We're monitoring this as we go. Should we swap places?
Yeah, sure.
Yeah. Okay, so while some of you are completing, we've just had another completion, we've got 12 so far. While you're completing that, I'd like you to also think about these 3 questions. So based on the data that we're collecting from the 20 participants here, or 19, because we're 1, I guess.
Yeah, that's true.
I'd like you to think about what the mean age might be, the gender split, so what percentage are male, what percentage are female, and the mode, so the most commonly occurring level of A1 to C1. And to explain A1, I'm sure most of you are aware, A1 is beginner, so, say your name, numbers, that kind of stuff, all the way up to C1, which is basically fluent. Okay, so we're looking at that data now. When you're ready, if you can start typing your answers in the box. So, for example, you could put mean age and then a number. Gender split, 80-20. Most common CFR level, C1, unlikely, but Good, we got some numbers coming in. Average age 40. Okay, interesting. 42. That's interesting. Okay. 36, 40 to 45.
Right. This isn't useful. Let's just go with this. No, they can't see it.
You're muted.
We're not muted. Yeah, apologies everybody. We're trying to do the we're doing the data wrangling on the fly. So forgive us while we just sort of throw these
and we mutter as well.
Throw these slides together.
What else have we got? Just turned 53 last week. That's very specific. And thank you.
Right, and then what is your speaking?
I'm wondering if that's a mean age, though. I'm thinking that's probably not a mean age.
Yeah. Okay.
Gender.
Let's throw this up here as well, and then.
So just to be clear, we're looking at the averages here. So the average age. I mean, feel free to show your age as well. That's very nice of you to do that. But also the gender split. So we're looking over the whole group, and the mode is what most people can do in French. So are most people in the group A1? Are most people in the group B1? That kind of stuff. Usually gets grumpy around 48. Yeah, I would lower that age.
Yeah,
I'm fairly grumpy.
Yeah, forgive me, folks. We're almost there. I'm just glad that it's working to some extent. I was worried that it wouldn't work at all. So I called
We got 17 responses actually,
Yeah,
which is very good.
We
out of
did.
20.
We did indeed. So yeah.
So should we have a look at the guesses then? So what have we
Let's
got?
have a look at the guesses. So yeah.
So what have we got for age?
Yeah, age, we're looking, so 40, 42, 36. Let's have a look at age then. So yeah, here's the ages. So yeah, 7 people are 40 to 49. So that would be the mode, wouldn't it?
Yeah. So we're going to go with mode, I think.
Yeah, we'll go with mode. Unfortunately, the Excel spreadsheet doesn't give you
clean averages.
Clean averages. So yeah, we're just going to have to go with this. So I think people were pretty close, were they?
Yeah, I mean,
yeah, people saying in their 40s.
So we've got someone that's over 60. That's great. Welcome. We've got nobody less than 20.
Yeah.
Which is good. Should we say what if you click insights? What's it say?
I don't know. That's on the thing. What does insights do?
It tells you the summary. 8%. Well, that's pretty
it's not very useful. So let's move on to the next one then. So next is, what is your gender? What did people say? They said gender 70-30. Well, you were right in that there are mostly females, 1 other, and 6 males.
So it's more, yeah. So it's more like
70% female. So lots of people were saying that there would be more females than males.
True.
Yeah.
Yeah.
Okay, good. And then the last one then is, what is your speaking proficiency in French?
Wow, we've got a C1. 2
Wow.
C1s.
So to whoever it is that C1, I do apologize profusely for my attempt at speaking French. So yeah, we've got A2. People said A2, 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 B1, and
it's not interesting. The one nobody said A1, which is the right answer.
Yeah, interesting, isn't it?
You assumed C2s.
Right.
Yeah. We've got any French people in the room?
No C2s.
No.
Yeah. Okay.
Interesting. So a kind of an overestimation of ability. Generally.
Yeah.
So A1 is the most common, which we could expect. What I would say is we're going to use this data again, by the way. It's not, this isn't just for the warm-up. So we're not making you deliberately jump through hoops. Okay, shall we continue?
Yeah, let's continue. And thanks very much for that, everyone. Thanks very much for putting in your data. We really appreciate it.
Yeah.
Let's move on. Yeah.
Okay, right. So we're going to start by talking about the model card framework. And again, really the idea of doing this is to respond to several challenges. First of all, there is no standardized approach to understanding how well a model works. So is it good or is it bad? Is it fit for purpose? Isn't it? There's no standardized approach. So really, we've got to think about how we can have a common language or common communication of that. If you look at a lot of the materials on websites of tests that are auto-rated, good luck understanding a lot of it. I mean, I've been in this field in terms of the validation. I don't have a background in data science, and there's loads of it that I don't understand. So it's inaccessible to a lot of us, basically. Yes, another challenge that we've really come across, because we've been working with partners that develop these solutions, is that they're reluctant to share information. It's confidential or it's proprietary, and maybe they feel threatened that we'll be using that information to develop our own solution. So this is a big challenge. Without that information, it's difficult for you guys as users to actually decide whether or not we can say it's fit for purpose. When you look at auto rating these days, bias is the key word, really. Everyone's talking about it. However, if you look at the technical documentation provided by tech vendors, what you'll see is that bias is generally not included. And we'll go into more detail later. And so it's either assumed that there is no issue with bias, or there is a lack of willingness to share that information. As we say later, bias is almost inevitable. The question is, does it impact on the test use? The other thing is there's little guidance available from the literature. In some fields, there is more guidance about how to evaluate different systems. For example, in assessment, we have frameworks that help us decide whether an item is working, whether the difficulty is being correctly calibrated. But in terms of auto-rated assessment, there's little guidance. Okay, so there are the challenges. Here's a potential solution then. This is the model card overview, if you like. It's a system developed by Margaret Mitchell. It should be 2 L's. I know there's only one. She worked for Google, I think, in obviously the model language field. And actually quite a lot of co-writers. So really, you've got a lot of expertise across model development. So this is where it's coming from. And it's designed for those solutions, obviously AI driven, but supporting higher stakes decisions. So this could be, for example, facial recognition that links to access to systems, or you know, the sort of data that is used to decide credit ratings. These are high stakes decisions using modeling. So the real value, in my opinion, of this model card is that it selects types of evidence in a way and categorizes it in a way that means for us, we can say, okay, is that there? Is that not there? Is that what we need to see for the test use that we're using it for? So that calibration of evidence and that categorization of evidence from experts in the model language field is, we would argue, very relevant for language testing as well. And I think a key thing is that the validation isn't designed for coding professionals. So you don't need to be a data scientist. It's designed so that a wider range of stakeholders, including us, teachers, test users, can start to make decisions on whether this stuff is working or not. Okay, in order to illustrate the framework, we want to contextualize this using a product. And so we basically took the concept from Margaret Mitchell's paper and we applied it to an auto-rated assessment that the British Council has been developing in partnership with the IELTS partners. So what is it? Well, IELTS Smart Learning is a speaking test preparation app. So that's basically a series of practice exercises going from low level to high level. It's auto-scored, of course, and users can also receive formative feedback on their work as well. The placement test then is the focus of our validation. It's the first thing the users come across when they start. So what it is a range of speaking tasks that represents the same construct, represents the same skills that are being tested in the ISL product, the IELTS Smart Learning product. Once you finish the test, there is a recommendation of level from A1, as we said, absolute beginner, up to B2. And then the user can decide where they start in the app. The idea is to make it more efficient, so you're not using materials that are too easy or too difficult. It is only an option, though. You can actually choose to avoid or ignore the recommendation. As I said, it's developed by the IELTS partners. At the moment, it's only available for Chinese L1 users in China that are preparing to take high-stakes tests like IELTS. So that's IELTS Smart Learning. I think I'm passing
over to me. Where's the mouse gone?
It's flying over there.
It's flying over there, right, okay. Yeah, I'd like to basically do an overview of the model card. The model card is essentially a shopping list for information about the model. It's kind of like the nutritional information that you get on a packet of food in a supermarket. You can take a quick look at it and you can get all of the most salient information about it. There are actually more parts to it than this, but we've picked the parts that we think are most salient for us to talk about today. So we're going to talk about the model details, the intended use of the model, and actually the converse of that, what the model is not intended for. Factors, this is talking about risk factors and some metrics. And because we think this is one of the most important elements, we're going to really drill down into this, and we're going to give you guys an opportunity to actually have a go at this using the data or the metadata we used to train this machine model. Then we're going to talk about the training data, the evaluation data, essentially the data that you use to make the machine intelligent, and then the data that you use to test to whether or not it is, and then some ethical considerations. First of all then, intended use. As Trevor said, the IELTS Smart Learning Placement Test is ultra low stakes. You can do it if you want to. If you do it, you don't actually have to follow its recommendations. And in fact, you can do it as many times as you like. It recommends starting practice level, the aim of which is to make sure that wherever you're learning in the app, you're at the best level for your level of ability. It's focused on L1 Chinese users. The idea is that it is used by Chinese school students and young adults between the age of 14 and 19, and it's aimed to be used in all regions of China. As I said earlier, we need to also look at the converse. What is it not intended for? Firstly, it's not intended for high stakes decisions on performance. So it's not intended to be used in the same way as IELTS or TOEFL or any of these high stakes tests. It's not intended for use by non-Chinese L1 users. So if it was used outside of China, that would be it not being used for its intended use. And then finally, young learners. It's not intended to be used for learners below the age of 13. And the reasons for these stipulations will become clear later. Next, we're going to look at factors, what we're calling risk factors. And this is what we really want to dig a little bit deeper into. I think actually Trevor was going to take over at this point.
I think we agreed that. I'll do it.
Yeah.
No, you, yeah. Yes, I mean, factors here, we're talking about risk factors. Why a risk? Because it can affect fairness and reliability of the model. And basically saying that, you know, if we don't identify and evaluate the impact of these factors, there could be an effect or an unfair effect where one group gets a higher or lower score than another group. So in terms of our smart learning, we were looking at gender, age, city tier. This is an interesting one because in China, different cities have different levels of education. So for example, in Shanghai, you're going to have at the same age, you're going to have students doing different things, probably among the higher performers compared to cities in the southwest of China, for example, that are lower tier. So we did put that data in. Also user L1, in the case of our smart learning, it's the same. But if you're doing a global test, then you're obviously very interested to see what accents, what first language users you have in that data set. And ideally, and this is the key point, what goes in the training set, the population in that training set that's used to, as Will said, make the model intelligent, that should reflect the users. So you want to have the same representation in the training data as the users of this product. So for example, for IELTS Smart Learning, in a way, it's quite easy for things like L1 because we're looking at Chinese only within the Chinese context with Chinese L1 speakers. It's much harder if you're looking at a global test. So, you know, for example, with Aptis, if we were going to use auto-rated technologies to rate Aptis, we would need to be very careful about the representation of different L1 speakers. Okay. So we can now look at something completely different. Before we look at the factors, I wanted to give you a very, very basic overview of how auto rating works. Now, this is going to be very, very simple because this is obviously very complicated, and each box you're about to see contains lots of smaller boxes which contain lots of different algorithms and technologies. But it's important that we look at the overall process because it does provide insights into how bias can affect the output and also the fairness in terms of different user groups. So we're looking first of all at automatic speech recognition, which basically is the process that converts an audio signal into text. When you say, "Hello Siri," and she responds, there's a speech recognition part in the middle of that, if you like. For our context, not everything is measured through speech recognition. For example, we can measure fluency using the waveform in some respects. And also there are elements of pronunciation that can use waveforms as well. So just the curves. But if you're looking at measuring, for example, the relevance of a response, the lexical range and accuracy, the grammatical range and accuracy, you need to turn the audio into a text representation. You need to analyze that to bring these through. Therefore, it's like the bottom of the building. If this doesn't work and you're getting rubbish to be analyzed, then the scores that you get for these traits, say, for example, in speaking or writing, are not going to be accurate either. So let's have a look at a system. Now, here's over to you. What I want you to do is reorder the system. So looking at A to E, which comes first, which comes second, third, fourth, and fifth. And when you're ready, I'd like you to type your answers in the box. We have actually done this before, and we did have quite a range of answers, including quite a few correct answers. So I'd be interested to see your answers. So I'll give you maybe, I don't know, 30 seconds, a minute to look and decide which order you think the automatic speech recognition process follows. It's a good question. C is someone speaking. So C is someone speaking, and B is the written text. Let me know if there's any other questions, but I'm not going to tell you what any of them mean though.
C-E-A-D-B.
Okay, C-E-A-D-B. Two people saying the same. Adrian, nice to see you, Adrian, or well, to your name. C-B-E-A-D, C-B-E-A-D, C-B-E-A-D,
right.
C-A-D. We have, I think we've got 2 correct answers so far. So now we know what it is. I've just told everyone what it is. That's
just
great.
told everyone what the answer.
Oh dear, never mind. That's the answer. So the answer then, the process. You start with, I knew I had something fancy. There you go. So we start with the speech, obviously, that's where we start. Signal cleaning is really important because you get a lot of data in a waveform that is not helpful and distracting. So the signal is cleaned, it goes into the acoustic model. So what's that? Basically, an acoustic model is a massive data set where you're matching what someone says with lots and lots of recordings of what people have said. So at acoustic level, you're looking at that match. And that's the first stage. But it isn't enough. For example, if someone said, I like the sea, the word C as a homonym could be S-E-E, it could be S-E-A, and it could be the letter C. And the machine from an acoustic model is not going to know the difference. So then you go to the language model, and the language model is a bit like a more complicated version of your predicted text message. You know, when you start writing and it completes the sentence. Think about that technology. And what you do is you combine the acoustic model and the language model to make the best possible prediction of what that text can be. Does that cover it?
I think it does, yeah.
Okay.
Any questions?
Yeah, any questions? Actually,
any questions?
There's quite a lot we're throwing.
There was a lot to unpack there.
Yeah. Don't worry if not. Because we might not be able to. We may not be able to answer them.
Yeah, that's true.
That's true.
Yeah.
Okay, here we go. We're going to carry on.
No questions. So let's continue.
Ooh, right. So, let's have a look. Oh yes, a couple of things I didn't mention. In these slides for a while. So first of all, the acoustic model and the language model requires training. And in terms of the acoustic model, you need lots and lots of speech samples, masses of them. And the model is only as good as the speech samples it's used to train. Likewise, the language model is based on a large corpora, so lots and lots of written data is put in there. And again, the language model is also only as good as the text that is used, or only as good as the appropriacy, perhaps, or the cleanliness of the data that is used to train that model. And so one of the first questions we're thinking is, where does this training data come from? Is it relevant? Does it link to my context? For example, user speech samples. If we're looking at, I don't know, say we're looking at a young learners test for, I don't know, people in Bulgaria, you would want young learner Bulgarian samples in that acoustic model training. If not, you're going to say, well, are we going to capture all the features? Is there going to be any bias against Bulgarian young learners if their data isn't in the training sample? So these already, we're starting to think about, where does it come from? Where does this data come from? Is the bias in it? Does it impact the use of the test for the users? Okay, scoring model then. This is even more simplified, but anyway.
At what stage does NLP come into play? Thanks for that question, Bushra.
Well, I mean, actually, it can be used in so many different stages. So you could use NLP in speech recognition. You can use it in scoring model and lots of different stages as well. And I'm not an expert on this, so I wouldn't be able to tell you about all the different processes. We've got Adrian in the room who probably know more about it than I do. But to put it simply, NLP is like an engine that will actually give you a response that you need at a particular workflow. So NLP is used for different things at different stages in the cycle. So we'll have a look at this cycle and you can sort of have a look. Thanks for your question. It's a very good question. So in terms of the scoring model then, what we're saying, we start by looking at the human rating scales, because a scoring model is a predictor. It basically says, how can we predict what a human is going to do when they mark a test or a response? So we start with the human. So we look at the rating scales, we look at sample responses, because we're interested to know what is being measured. In assessment, we say it's the target construct. You could say it's the skills we're interested in. Maybe you're only interested in the fluency because it's a read aloud. Maybe you're interested in the range of lexical resource. So it does differ depending on the task. And then we look at the features, because we're saying, what are the predictors of those skills? So that feature mapping happens. Then we evaluate the features from the responses, and that's the training set again, rated at each band score. So we could say, okay, for a low level, we expect these features that predict this type of skill. So if it was, say, for example, it was fluency at the low level, maybe the features would be hesitation. We would expect long hesitations at the lower level and shorter at the higher level. That's a very simple example. And once you've got these features, you've got features indicative of level, then the model, the regression models, etc., get to work and balance everything. And they try again and again, and they iterate until they find the best combination of these features to predict human scores. This is only one type of modeling. This is like a supervised. So, it's more transparent. There are lots of deep learning models that obviously don't work in this way, but this is a simplified form. Right, so it's over to you again. We've got 5 again. If I do that, yes. So we need to think again, stages 1 to 5. What happens first, second, third, fourth, and fifth? And if you could put your answer in the chat again, that would be great.
And just for clarity, C is the score.
C is the score, B is someone speaking. Yeah. Oh, good question. ASR is automated speech recognition. So E is what we just talked about. So that whole process of speech recognition is E.
Oh, we've got one. So thanks, Bushra. BEADC. BEADC.
Okay.
Any other thoughts? Oh, thanks, Daphne. Yeah, another BEADC.
I'm not going to say anything.
I'm seeing a pattern emerge.
No, I'm not saying anything.
Okay.
So, is anyone else going to put anything different that's wrong?
BEADC, BEADC. Very good. Well done, everyone. Yeah.
Yeah. So BEADC. So feature processing obviously happens first, and then we move on to the scoring model. You'll notice that the second orange arrow, that's surprisingly hard to say, avoids the ASR, and that's example where we're looking at features of the waveform that I discussed earlier. So not all the features require the speech recognizer. Okay, again, so user responses will inform the feature processing, not just the responses, also rating scales and various other things. The scoring model itself, we need 2 things, crucially. We need the human ratings and we need the user responses. And again, when we're thinking about questions that we want answered as users of this, where does this data come from? What user responses? Who rated them? What raters? How do we know the raters were right? User responses, where did the user responses come from? What users were actually sampled? What were their demographic characteristics? Any questions on that?
And yeah, just one further point on that. I remember that ASR represents what we were talking about before. So that means that the scoring model is also reliant on all of the inputs to the ASR.
That's right. So all of the potential, the training, the data, any bias in ASR can be passed on to this stage as well. Yeah, very good point. Okay. Right, on this. Yeah, it's my favorite slide. So what have we got? We've got 8 Americans and an Irish person. Right, I knew that there's a reason that this is here. Yes, so in the training data set, this is an example of obvious bias. So if you were training, for example, a speech recognizer, and 8 out of 9 are US voices, and 1 out of 9 is Irish, what do you think might happen? Answers in the chat box. So is this potentially a source of bias or not? Yes or no? Feel free to say why. Okay. Yes, bias. Yes, bias. Thanks. Okay. I don't think we probably need to keep going on this. So it's this very famous article that I'm sure a lot in equal representation of the sample would lead to bias. Thank you, Bushra. That's exactly the language we are talking about. So the reason I chose this is because a particular test that we know is primarily trained on US data basically flagged an anomaly when flagged an anomaly. Yeah. So anyway, Irish vet fails oral English test, even though she's fluent, she's got some degrees, because there wasn't enough Irish speakers in the data set, likely to be the speech recognizer, we don't know. So it is important, and joking aside, these are decisions that affect people's lives, high stakes decisions. So bias is important, and it's something that we're addressing today. How are we doing for time, by the way?
We are 35 minutes in, so we've got plenty of time.
Is that over to you? I
think it is over to me.
Okay.
Yeah. Yeah, so back to your data. Here you can see on the right the data from the survey that we ran earlier, showing the distribution of ages. Now, if we think back to the ISIL product that we talked about, we said that in the ISIL product, the aim of the product was for it to be used by young adults between the age of 14 and 19. So what I would like you guys to do is have a look at that graph and think, how applicable would that data be to that target group? And do you think there is an issue with bias? Answers in the chat box. What do you think?
And again, just to, an additional point, we're assuming that we're building an auto rater for ages 20 to 60 plus. That's what we want to build. We need the speech recognizer, we need the scoring model. That is the data. And obviously we've got 20, but imagine that's like 1,000 samples, but we've still got that representation. Any problems? Yeah, just to say the target group, I think I've just said, we say it again, the target group is 20 to 60. It's your whole set. We're saying that you want to have everyone inclusively represented as a user of this product.
Oh, sorry, because I said 14 to 19 and it was the same as the ISIL.
Oh, sorry, have I just completely sabotaged your
Okay,
point?
so one step at a time, one step at a time. So firstly,
sorry,
no, that's all right, Trevor. So one step at a time. Do you think for a target group of 14 to 19 that this set of data would be useful, or are there issues? What do you think? Please type yes if you think it's useful, or no if not. Not really, from Karen.
Yeah, okay.
Yeah, it's not representative at all. Yeah, absolutely.
Okay.
So then my next question was going to be what Trevor said. So let's imagine actually that we're not focused on 14 to 19. We're focused on the whole distribution between 20 to 60. What do you think? And I think we got quite a good.
We got a good answer.
We got quite a good answer. So 20 to 39 is underrepresented, and 60 plus is overrepresented. 60 plus overrepresented. Okay. Any other thought? Any other? You've got a new message.
Not any.
So so Ricky. Okay. So 60 plus shouldn't be in there. I mean. Why do you say, Ricky, that it shouldn't be in there? Why shouldn't 60 plus be in there? Because I said 20 to 60.
Oh, okay. That's a fair point.
Yeah, absolutely. Yeah, you're absolutely right. So Daphne is saying not an even representation. Yeah, we see this a lot in data. You get a what looks to be close to a normal distribution, and this is very problematic when you're training machines, because the data usually looks like this, which means you have lots of data in the middle, 40 to 49, but as you get to the extremes, you get less, which means the goal is always to try and find the data at the extremes.
So really good question from Adrian. Would you like the distribution to match the target age distribution or be equally flat? Now, this is a question of really it's about money, and it's about target, because we've just suggested 20 to 60 as a product, and it is possible that you get that range. What cynically people would say is, well, how many users would you have of the different age groups, right? And then you would say, well, if most of our users are 40 to 49, then we would want most of our user data 40 to 49.
Sure.
So yeah, I mean, I think that's a very good point, Adrian. And if money was no object, I would argue you would want a flat distribution if you could afford to do it.
Yeah. Absolutely.
Yeah, exactly. That's exactly right, Adrian. So it's like every person counts. If it's a high stakes decision, why are we saying just because there are fewer 60-year-olds, they're not going to get the same equal opportunity?
Yeah.
So that's why this is it's totally about fairness. What else we got?
And Karen, yes, presumably you'd want to discriminate well at each age level, so a good representation in each. And yeah, actually, when we were training this model, we used what was then the current iteration of the model to rate all of the future data, so that we could choose the data which was likely to fall at the extremes, so that we could flatten it.
Sorry, I've seen Ricky's comment there. Yeah, exactly. To make it flat, make it fair. However, it's often a question of money, unfortunately.
Yeah.
And also, we don't usually get this data as users. It's only that we've been, working very closely with the partners, so we've been able to get metadata and do this stuff. So, I mean, if you look at the stuff on the market, they're not going to show you what the distribution of their data sets are. And that is one of the big problems we have as users of this technology.
Yeah, but being aware of this metadata while you're training shows you that there might be problems before they happen, which means that if you have limited budgets, then it means that you can focus that budget on the extremes. Is there some way to figure this out statistically?
I mean, we've done, for example, yes, you can if you're looking at best match. But if you're figuring it out statistically, you're going to be having the problem that Adrian mentioned, because outliers, if statistical outliers are still people who are, decisions are being made on their performance. So statistically, yes, and you'll probably make data savings and money savings, but there's a fairness issue. Andrew, makes model more accurate for the better. Exactly. That's exactly right. In the middle of the curve, you get more accuracy regardless of the variable you're measuring. So it could be age, it could be proficiency or accent or whatever it is.
Yeah, absolutely. Yeah.
I think we're going to need to move on, but this is fantastic, guys. Thank you so much for your input and contribution.
So that was drilling down into the data that you guys shared. So now we're going to go through the same exercise again, but this time we're going to focus on the data from the ISL placement test. So how do you decide which factors are in court? Okay, we've gone through this. Yeah, so now we're looking here at age, but not age related to your data, age related to the data from the ISL placement test. So as we said before, the goal of this placement test is to provide an accurate recommendation, that should be, across the target age range of 14 to 19. So please have a look at this data, and just so that you know what you're looking at. On the left, what we have is a pie chart that shows you how much of the data contained metadata.
I would explain that. Sure.
So what I mean by that is, let's say, well, N is 344. So you can see that the red portion of that 344 data points don't have any metadata. So we don't have any data about their age, the user. Whereas the blue portion, we have the data about the age, and that's what you can see in the graph on the right.
Yeah.
So what we'd like you guys to do is just have a look at that and tell us, what do you think? Hang on. How do you think that this data supports the goal, providing an accurate recommended score? And how do you think this data undermines the goal? So what do you think? How does the data support the goal? How does the data undermine the goal?
Okay.
Please put your answers, thoughts, questions into the chat.
Ricky, do you mind sort of expanding on that?
Where are the big holes, and why do they cause uncertainty?
And what uncertainty are we talking about? Yeah, okay. Good.
Yeah, absolutely. Yeah, that's a really good point.
That's right.
Yeah, if you don't know what the metadata is for a large chunk of your data points,
Completely change.
it completely changes the representation. We need transparency. Yeah.
I mean, it links to your point on data governance, doesn't it? So, you know, it's not just about transparency, it's about having it.
Yeah, absolutely. Absolutely. So yeah, Ricky, you've really nicely summed up the pie charts. How about the graphs on the right?
Very murky representation.
Very murky representation. So Cheryl, when you say that, are you talking about the pie charts, or are you talking about the bar charts? Yeah, I would absolutely agree.
Yeah. So data to be treated with caution.
Yeah, Alice. So yeah, the goal is to provide an accurate recommended score for the target age range. So that's 14 to 19. Yeah, Ricky.
Nailed. Absolutely nailed.
Well, actually, yeah, we don't know if we haven't even got a 14-year-old.
Because we don't in the data we have got, but because we've got so much data we don't have, we may have.
Yeah, absolutely. Absolutely.
Good.
Let's say, for sake of argument, that we have all of the data points and the distribution is still the same. So let's imagine we have all the data points, but the distribution is still the same. Okay. What do you think? Is this data useful? Does the data support the goal, or does the data undermine the goal? How could we improve it, Ricky? What would make it better?
Yeah,
that's it.
Yeah,
yeah, more data outside of our target age range. Yeah, the majority of the data 2021, which, although not horrifically outside of the range, is still outside of the range, so it's problematic.
I mean, if we sort of go back to how that affects the model training, what we're saying really is that as long as the features of our 14 to 19, in terms of, say, we talk about speech recognition, as long as they are close enough at 20 and 21, then maybe we don't need to worry about this. And that links to Karen's point about factors. So in this case, we might say that this factor isn't a particular problem. However, to give you another example, that in another project I've been involved with, if you had, say you're looking at the younger spectrum, and you didn't have any learner data for 5 and 6 year olds, because they speak in such a different way, you couldn't use data trained, like the data you see here could not be used with young learners, no way, because the pronunciation features are so different.
Yeah.
Not really useful because the assumption is that the languages. Really, we're not, I mean, not really, because obviously we expect that within a certain range, you're going to have a certain age range, you're going to have a lot of proficiency range as well. I think there is a point though, and that is that, I mean, for IELTS Smart Learning, we're looking at A1 to B2. So if we got, for example, everyone was, I don't know, between 30 and 32, and we also found out they were teachers, for example. And what we're doing then is we're training the machine on, high proficiency above the target range of the product. So that's an extreme example where you would be right, Alice. I think, but just to be really clear, we would expect a range of proficiencies at every age if they're second language learners, if that makes sense.
Yeah, this is more about what the machine is measuring rather than about the proficiency.
Yeah, yeah.
Because the connection between the two is very complex.
Yeah, agreed.
We've got another question from Damien. Is it possible to compare two different groups of data? For example, inside and outside the range of 20 to 21-year-olds and 14-year-olds?
Yes.
And how different they are? Yes.
Yeah, I mean, I've been doing that actually, and so it's out of scope for this presentation, but a workshop even. But we were looking at bias between the machine and the human at all the different ranges, and we can use many-facet rash measurement bias interaction for anyone that's interested. Anyway, it's a statistical process that will actually break it all down for you, and it will tell you which ages are most reliable. And for me, I think that is a massive thing that we should all be doing.
Sure.
We'll talk about that later.
And the biggest problem here is if you look at the graph, I know that the writing's very small, but you can see that apart from 20 and 21, the number of data points is actually below 10 for all of the other ages. So any comparison would be quite difficult between, say, 18 and 19 and 20 to 21, just because the sample size is so small,
and you end up with very high standard errors, so that any interaction that comes out of these analyses can't be used. The data that the data I was using variables with a data sample that the standard errors were low enough for us to have confidence in any statistical differences.
Yeah, absolutely. Okay. Right, what time is it? It's 51. Should we do one more?
Yeah, I think we should.
Okay. Next is tier. And just to explain to those who live outside of China, in China, the cities are tiered. And essentially the tier given to a city represents the socioeconomic status of that city. So the tier 1 cities would be Shanghai, Beijing, Guangzhou, Shenzhen. The tier 5 cities would be small provincial cities. And the assumption is that you have higher economic, higher socioeconomic situation in the higher tiers. So what we wanted to do was have a look to see which tiers which tiers were represented in the data. Forgive me, I've lost my cursor again. Again then, so the claim that we're making, or the goal, I should say, of the machine is that the placement test provides an accurate recommendation across tier cities. Because at the beginning, remember, we said that we were trying to cover the whole of China. Yeah. So what do you guys think? Have a look at this data. How does the data support the goal? How is this data supportive of the goal? And how does the data undermine the goal? As before, the pie chart on the left shows metadata representation. The red part shows that there was no metadata for those data points. The blue part shows that there was data.
I'm just going to address another question, a really good question from Alice, which is saying more data, less bias. Yes and no. So actually more data can really sort of cover the cracks, if you like, particularly what we call the tails. So that could be like the lowest and highest. You've got more data, then you're going to have, relatively speaking, more on the tails as well. And we generally find that there are minimum requirements. So, if you hit a certain number of data points or data samples within a particular group, then we have less bias. The problem is that you need to be very clear on what data it is. Yeah. Because what we found, this is another finding that's beyond the scope of this project, but when we were training the engine, we had a scale of 0 to 6, and we had like 80% at 3. And then we got more and more data, and it was still 3. So we were training band 3 really well, but not bands 1 and 6. So what actually we did is we searched for quality data. In this case, it wasn't more data, it was the data that we were lacking. So I would say more data superficially might help you, but you still need to dive into it to make sure you got your representation.
Yeah, an absolute black and white example of this would be, so for the ISIL placement test machine, the ASR, the automatic speech recognition that's used, is trained on, am I right, hundreds of millions?
Yeah, 10 million a year.
Yeah, it's 10 million pieces of data a year for the last decade, I think. So you're talking about unbelievable amounts of data, but it's all Chinese.
Yeah.
So if you were to use that ASR outside of China, there would be a huge bias because it's not trained on the data that is the data that you would want for the target group.
Although I would, to qualify that, it may work, but you would need to revalidate at the very least. So quality over data quantity, you do need both. You need a certain amount of quantity, but you need quality as well.
Yeah.
And you can, as I said, you can paper over the cracks with quantity, but it's, you know, you really do need to dive in and analyze what you have, even if you have a massive data set.
And also with quantity, you can also get some very weird anomalies in the data with some very strange biases that may not come out initially, but may come out further down the line. So you have to be careful with it. And that's the whole point of these model cards, is to try and make this as transparent as possible so that people can make judgments on what they're looking at. Okay, yeah. So paper over the cracks with quantity cities in the training sample. Tiers 1 and 2 are overrepresented. Yeah, absolutely. If you look at tiers 3 and 5, well, 4 is non-existent, and 3 and 5 are very low. Yeah.
I would like to sort of go back to the point of assessment here, because people could say, well, why does it matter? Surely different levels just mean different proficiencies. There's a problem with that. In China, you have different textbooks in different cities. Different textbooks mean that kids will be doing templated answers in different ways. So if you're capturing, you know, lots of samples from a particular textbook, that could easily become the right answer. So it's not just about, well, it is, as Will says, it's about the socioeconomic difference, because the education is also strated by tier as well. So this does matter. It's not just a case of saying, okay, Shanghai higher average than, I don't know, Kunming, for example. It's the features as well. We've got lots of questions.
We've got lots of questions, but I'm speaking to the original questions related to this PPT. I think we've got some ideas. So yeah, Bushra Ahmed says, not sure if there's any data from tier 4 cities in the training sample at all. Yeah, tiers 1 and 2 are overrepresented.
Yeah.
Ricky says underrepresented in tiers 3 and 5. Yeah, so that's focused on the training, but what do you think about the test data? What's the issue with the test data? Have a think about that. And then should we look at some of these
questions?
Yeah, so Ricky says, big commercial conflicts with tier, presumably. Test providers make most money from the rich tier 1 kids, so more commercial incentive to represent them in your data.
I would say there's a couple of things there. I mean, first of all, in our experience, there are actually more opportunities for technical solutions in lower tier cities. Why? Because they're often cheaper. So we've seen like emerging markets within China, and I'm calling it an emerging market, a 3 to 5 city, because it's cheaper than having tuition 1-to-1. So but if we go up, sorry, can I go back to that question? I think the problem is it's easier to get data from tier 1 cities. Because that's often where the bigger language schools are, who partner with us, who provide us with data. So it's often about convenience, actually, rather than targeting rich kids. Because again, actually what we're finding is that the lower income groups are able to afford auto-rated scalable solutions as an alternative to expensive 1-to-1.
Yeah. Is there a way to record these chats? Quite useful, all of the opinions and responses.
Yeah.
I think actually, Jonathan Dixon, this is being recorded and it's going to be shared on YouTube.
Yeah, I think it is.
Yeah.
But so, I think you were saying, is there a way to output this as a text? Maybe.
I think there is a way to output the chat as well. I don't know if that's built into the functionality, but I know that Zoom has that functionality. So that will be a question for the organizers about whether or not they want to share the chat and questions with the video.
Yeah.
Yeah.
Because the problem is obviously we're responding in audio form or media form to text. So without our responses, it doesn't make sense.
Yeah.
So yeah, interesting.
That's an interesting point. We'll have to discuss that. But that's good. That's good.
What's what we got here?
So Ricky, well, even if right now most of your test takers are tier 1 and 2, long term, as everyone gets richer, you expect more test takers from 3 and 5.
Yes, you do. And because we see more and more people from these areas showing interest, they become partners at the trial stage. We get their data. Very good.
Yeah.
Very good point. Okay.
The final point that I'd like to make about this is just the difference between the test and the train, because let's imagine that for the training set that 3, 4, and 5 were really well represented, but the test was still the same. Then obviously we've got a validation issue.
Yeah, exactly.
Because if you're validating based on data that only represents 1 and 2, you have an issue.
Yeah, and I think basically what Will's saying is that the test data set representation should reflect the training, but should be independent. I mean, one of the things, I mean, you know, we were talking about questions that we can ask as users. And one of the questions I ask is the testing set independent from the training set? Because there are ways of using like cross validation, they call it cross validation. But the problem is, if you're validating from the same data set, you get higher accuracy, you get higher reliability. And it's not reflective of what happens when you get live test takers coming in. They are a independent test set, if you like. So when we're validating, we should use the same principle. So it's one of those things to bear in mind.
We have half an hour left. Have we got time to have a look at gender as well?
Yeah,
okay.
Good.
Okay. Again, essentially this is the same activity, but now we're looking at the gender data. Again, the claims, the goal, ISIL placement test provides an accurate recommendation across gender groups. You obviously have a cutting and paste problem here.
Well, it's consistently wrong.
Yes, it's consistently wrong.
Well,
so that's good. Yeah, so provides an accurate recommendation across gender groups. On the left, the pie charts are metadata representation, and on the right, we have the gender representation. So please have a couple of minutes and think, how does the data support the goal? And how does the data undermine the goal? Please have a think and write your ideas, thoughts, and everything into the chat. And can I just say thank you very much for this wonderful questions and everything that you're putting to us. It's really good to have this.
It's brilliant.
Yeah, this is really brilliant.
I think we also need to say this is the first time we've done this, so we didn't know what to expect, and it's I would say it's exceeded our expectations.
Yeah, it's brilliant.
You know,
It's brilliant. This is a lot of fun. Yeah.
Thank you.
Thanks. So, any thoughts, ideas, questions? Everyone's having a good think.
Or going for a cup of tea.
Yeah. Putting the kettle on.
We should do that.
Yeah, we should. We should. Here we go. Perhaps better situation with gender than other dimensions. Yeah, I mean, there is more metadata coverage. It's it's about 2/3 or better for this. That's good. A little interesting as gender might not be binary. Yeah, that's a very good point. Absolutely. And that comes down to the data collection method. Does the data collection give the option for other or not? Yeah.
That's such a good point. And I mean, I think you're going to talk about that in lessons learned, don't you?
Yes.
About data governance. Yeah. Okay.
Yeah, absolutely.
That's such a good point.
That is a very good point, because it is very important to make sure that it isn't binary.
And I think just again, to go back to why it matters. Why it matters from a speech recognition perspective is that you're more likely to recognize potentially, if we said from here, you'd say potentially you've got more data from female, so maybe the recognition for female is higher. So that's obviously going to introduce bias. In fact, actually for our project, it was the speech recognizer was trained on lots of other data, like millions of data. So it doesn't affect, but it could do. It could do in some situations. So the two things we want to see is that the female and male are the same and they're reflective between the two. And as Adrian says, well, is female and male enough? Because if you have binary, then someone that doesn't correspond to those groups, are there any traits that are specific to that subgroup? Yeah, we don't know. And I think that's an amazingly pertinent point.
And it's important to point out actually that it is one model, it's not two separate models. So it's not like the machine listens, in inverted commas, and decides, okay, this person is a female or a male, binary split, and then rates them. That's not how the model works. So yeah, if that was the case, then that would be very problematic indeed.
I think what Ricky's saying is that compared to the other factors we were measuring, this is better.
Yeah, absolutely. The train and test, they are similar.
We need to capture variation within the gender subgroups. Karen, could you explain what you mean by that? And I know I'm asking for trouble now because I won't understand your question. See what comes back. Variation across what dimension, I suppose.
Yeah.
I'm asking. so I can be completely scuppered with an
Yeah,
answer.
the problem is that when you start subdividing, then those subdivisions can be loaded and cause
and small
problems.
small samples, so then you can't do any statistically meaningful analysis on them.
That's it.
Karen, we'll keep monitoring this, so if you can sort of explain it, or maybe give more detail on the variation, so not just typical.
Yeah,
Yes, exactly, that's right. I see your point. Yes.
yeah, absolutely.
And I think, again, you can see why machine learning is so linked to social issues, fairness, inclusivity. I mean, it just really, it's so clear from that, right?
Yeah, and that's why these model cards are so important, because it's important to push for transparency when high stakes decisions are being made, so that you don't get, for example, Karen's aunt is often assumed male on the phone. Yeah.
Yeah, I mean, at the end of the day, what we want, and in a way, this, like I say, it doesn't matter. It does matter when you're analyzing the data, but it doesn't matter in so much if you have representation of all these types of voices. So and that links back to, I think, a previous comment, which is like, we just get loads of data. Well, yeah, sure. I mean, the more data you're going to get, then the more likely you're going to have these, in inverted commas, outliers, which could cause problems and bias.
Yeah, absolutely.
How are we doing?
Yeah, we're doing okay, I think.
Okay, good.
Yep, so we've got 25 minutes left. Where are we going next? Yeah, so we've really drilled down into factors there. So if everyone can remember back 40 minutes ago, we were talking about the model card, we were talking about factors. So let's have a look at the second half of that slide.
Is it me?
Yeah, I think it is, yeah.
Oh, good.
Yeah.
Okay. Right, so we looked at the subgroups. I want to talk a bit more about this. So we're saying risk factors. The population risk factor is basically what we've just been talking about. What we haven't talked about is environment. So say, for example, you guys are using an automated solution in the classroom. One of the questions you need to ask is, well, how close are the kids sitting together, or the students sitting together? Are they likely to affect each other? If you have multiple user voices, the speech recognizer will go crazy, and obviously you're going to get problems with potential contamination of data. So it's a practical question, but you know, okay, so if the kids are sitting very close together, you need to use boom mics with what do they call it, the noise suppression, so you're not capturing the background noise. Connection and bandwidth will also affect the quality of the speech recognizer as well. So if it's low quality bandwidth, you're going to get low resolution audio, and that's likely to cause problems with the speech recognizer word error rates, for example. So we didn't talk about that, but it's something to consider. If it's a really high stakes test, then you need to have the bandwidth, you need to have the right headsets, the spacing in the classrooms, all these kind of things. Okay, so the data we've talked about, data coverage, is a problem. Obviously, we can't actually make concrete comments without having the whole data set, and I think Ricky made that point very clearly. Findings in relation to the intended use, then, the training data is older than the target demographic, and so I don't know why it's 16 to 9, it should be 14 to 19 there, because we had 20 and 21-year-olds. However, we were also saying, well, we don't think that the features of a 20 to 21-year-old may be significantly different to a 14-year-old. That's a question. And again, I mean, we've done a lot of validation work, and often it's about money. So what you need to do is decide which of these factors is going to be more of an issue. And this links back to Karen's earlier question. And if we're saying we don't believe there's going to be massive changes in pronunciation features that will affect the engine, then we would probably prioritize other things that were more of an issue. So say, for example, if gender is massively skewed towards one or different modes, as we've been discussing, or different subgroups, then maybe we would want to try to address that rather than addressing the difference between, I don't know, a 16 and a 21-year-old. Stronger representation in tier 1 and tier 2 cities we talked about as well. Yeah. Okay. See, this is really embarrassing doing this in front of Karen, but never mind. So there are lots of ways of doing bias interactions. We used ANOVAs. We also used bias interactions with many facet rash measurement. What does this mean, and why is it a metric? So let's start with metrics. So a metric, according to the model card, is a quality assurance. It's saying, what do we need to hit in order to say that this is fit for purpose? And if we start with bias, you could, some test providers, believe it or not, say there is no bias in my system. I'd be interested to see a systematic support of that statement, because in my experience there's always bias. The bigger question is whether or not that bias affects the scores and affects user groups. However, what we're doing here, this is very simple. What we're saying, we put it into a statistical passage. We used ANOVA's, would it be three-way, two-way?
It was, yeah, two-way and three-way. And what you can see here is the three-way ANOVA's.
Yeah. And basically, we don't want significance. So significance basically means that any difference in the mean score for the different subgroups is down to chance, not down to the fact that there are trends in the data that are different between these groups. So when we see here, we've got significances that are much higher. I mean, we say 0.05 in our field. Anything higher than that, we're sort of looking into chance. If we had very, very low significance, that's a big warning sign.
Yeah. It suggests effects.
Yeah, that's right.
But also, we also have to remember, if looking back at the metadata representation, we also have to take this with a pinch of salt and be very careful about any conclusions that we make.
I do want to show, I wasn't going to show this slide, but I know there's some people that like stats. I'll just go to the end. There's a slide here. Something we've done quite, and I think this is really interesting. So this is some output from many facet rash measurement. And what we're able to do with this is we're able to look at significant differences at the trait level across the human and machine score. So we're saying, for example, it's nice and complicated. If we look at human, for example, what we're seeing here, the first two are the differences in the mean scores. And what we're saying is that except this is the wrong slide, but never mind. What we're saying here is there is no significant difference, but we're looking at it across the human, machine, and male and female. That is the wrong slide, actually. But I think what we're saying here with this is that we have an opportunity with bias interactions to explore more than just interactions between biases at a general level. We're able to dig into that, and we're able to add it to my next slide, which is human machine reliability. Because usually human machine reliability is one score. What we're more interested in doing with bias is saying, well, what's the human machine reliability for these subgroups? And is there any difference? And that's what many facet rash measurement can do. Okay, is this me or you? It's me, I think, isn't it?
Yeah, or I can.
Yeah, if you want.
Yeah, so again, guys, it's the same question again. We've got some statistics here and we're asking the same questions. So we're saying ISL placement test provides an accurate recommendation, or no, recommend is right this time. Yeah, brilliant. Yeah, accurate recommended start point in the product. So when we look at this data, we've got a row correlation of 0.93.
That's Spearman's.
Yeah, yeah, so that's Spearman's row, and we've got exact agreement of 67%. For those who are assessment inclined out there, looking at this data, what do you think? Do you think this data supports the goal, or do you think this data undermines that goal? And remember, the goal is to provide an accurate recommended start point.
Yeah.
So what do you think? We haven't got long for this, actually. We've only got a minute or so. So yeah, we're running out of time. So any thoughts that people have? Do you think this is good? Is this for a low stakes test? It generally supports it. Ricky says supports.
Generally supports. Damien would assume that there's something in there that is an issue for you.
Yeah, very good, Karen. Absolutely, yeah. That is something that is often missing when people talk about. They say gold
raters, gold standard,
gold standard raters, and then when you ask them, what do you mean by gold standard raters? They find it quite difficult to describe what they are. Yeah.
Above that, above what? That's the question. For high stakes, people will want above that. Above what? Should we unpack this a bit?
Yeah, go for it.
High level of agreement. Okay, I think the first thing to say actually is that this data is very impressive. Why am I saying that? I'm comparing it to higher stakes assessment in global testing contexts. 0.93 is incredibly high, and we were very, very pleased with that data. What it means, what 0.93 means for those that aren't sort of Spearman kind of literate, 0 would be no correlation and 1 would be in effect a perfect correlation. 0.93 is very high. In terms of what is a good correlation, and that's, I mean, Damien was saying, you know, but what's good? And this links to questions that we ask as test users. There is no definitive answer. I mean, for really low stakes, minimally acceptable, I've seen like 0.7 as being, you know, for a practice purpose, fine. When you go to medium, 0.8 and above, high stakes up to 0.9, anything above 0.5, 0.9 is really high stakes. That's fine, that's good. So, you know, in effect, what we're saying for a low stakes purpose, and I think we've had a lot of supports here, this is great. In terms of the exact agreement, 67%, and anyone that does human inter-rater reliability will know that 67% is really impressive. And it was actually higher, and this links to Karen's point, it was actually higher than the exact agreement we had for the human raters. And we do talk about that in a minute. Any questions? Right. So how does data undermine the goal? Even human raters don't. Yes, exactly, Bushra, exactly right. Yeah. And actually, we don't always want them to agree, because some performances are between, for example, a 2 and a 3. And with those, you actually want 2s and 3s, and then you use what we call the fair average, which is a modified average based on rate of behavior. And then we'll get our 2.5s, which is probably actually, you know, a fairer score. So we don't want them always to agree, but we don't want, like, I don't know, 1, 5, and 7 for the same response, for example. So, you know, that's obviously an issue with the human rate of reliability.
And another very important point to make about correlations is correlations between what? So because we're talking about human versus machine here, what we're actually talking about is how well the machine predicts the human score, not how well the machine rates the
script, or
the recordings. Yeah. So it's very important to take that into consideration.
Yeah, absolutely, because what we know is the machine and the human don't measure the same things. So a correlation could be great if you have a certain type of student, but it could be a disaster if not. There was an interesting study done on writing assessors, where you have some very creative answers, and we have the same problem with human raters at you know, higher levels with high stakes tests. An unconventional answer can be brilliant and really marked down by a auto rater because they haven't seen them before. So that's why whenever you see a correlation, it's based on a data set. Yeah. It's not going to be all inclusive, which again links to our fairness. Yeah, we're going to need to keep moving.
And we are running out of time. Yeah, we need to get going. So yeah.
Okay. Karen's point again. There's no point in looking at human machine reliability unless you look at human inter-rater reliability. And to be clear, when we developed this auto rater, we used more stringent rating than we did even with IELTS. And the reason for that is that even though it's low stakes, it's scalable. So this machine, which is based on these human scores, can rate thousands, tens of thousands of students. So their impact, although low, spreads. Yeah. So it is high, in our opinion, it is high stakes, because even though the decisions aren't made, not big decisions are made, you're still giving feedback to a masses of people, you know, a whole, particularly in China, as you can imagine. Yeah. So what you're seeing here anyway is within one band, 91.6%. For human machine reliability, within one band was 100%. So actually the human machine reliability was better than the inter-rater reliability. That's quite common actually. But again, massive caveat, what is the data set? Always the question that we should be asking. Over to you.
Yes, so what then were the project findings from the model cards project that we were involved in? Well, yeah, as we've talked about to a great extent, is the current model fit is fine for low stakes purpose. No age bias was identified. Actually, there was no age bias identified. There was no tier identified, and there was no gender bias identified when we did the original ANOVAs. But when we did the multi-facet rash bias interaction, we found that there was some bias.
Yeah, and there was bias in age, which you would expect because of proficiency. So it was, to be honest, it wasn't something we were particularly worried about because we would always expect, again, a correlation between a higher proficiency level and a higher age group. The key thing is that we want to have as many of the age bracket users in the training set as in the user database. And we know there's a slight problem because they're slightly higher.
Yeah. As we talked about, the training set is older than the target demographic by a couple of years. So that's obviously an issue and something that would need to be looked at in future projects. Again, yeah, the majority of the data from tier 1 and tier 2 Chinese cities, especially in the testing data, the other tiers weren't there at all. So again, that is an issue. More research is needed. We have less than 50% metadata in some cases, although in some cases it was slightly better. So this is something that really needs to be focused on in future projects. And this approach shows us really clearly where more work is needed. And that segues quite nicely into my next slide. I'd like to talk about some lessons learned from this project. And I think my key lesson learned from this is that projects are complicated. They involve lots of different people from lots of different places, and communication between those people is difficult, and collecting all the data for model cards like this is really difficult, which means that this process isn't trivial. It shouldn't be taken lightly. And actually, most of the work is involved in data cleaning.
Yes.
Significant learning is required from all partners. Machine learning is really complicated, and it involves lots of different facets from often lots of different types of knowledge, which means that you very rarely get one person who can do it all. Which means that if, like with this model card, you are showing all of the salient factors related to a model card, it means that people need to learn about elements of the model that maybe they didn't know about before. Yeah. We've learned that this approach would definitely work better when undertaken from the beginning. We had to retrofit this because we did the model card after we did the data collection, the training and everything else. And that's why we have that's why we have a lack of the metadata. If we were to do this again, and this was of key importance right from the start, because we know it's important, we would make sure that we collect it, and then we would have much better representation, and then we would have a lot more confidence in the statistics that come out of it.
Yeah, I mean, I'd link this back to the a priori argument about test validation, which is we know that you validate from day one. And if we see the model card as a form of test validation, you start considering the data requirements at day one.
Yeah. The process can help us improve our scoring systems. Going back to the analogy that I gave earlier of this being like the nutritional information for a food product. If you look at it, you can see whether or not the food is fit for purpose. Is it what you want to eat? Basically this process is very, very good at shining a light on this. Although we do have to be careful because obviously this whole process is predicated on scrutiny, which means you have to really communicate well with all the people involved to make them understand that it's not some kind of witch hunt. And that's important. You want people to understand that it's a positive process, and it's not, the scrutiny isn't pointing fingers at them saying that they're not doing their job properly. And that's a very hard process to manage. And then finally, seems to have disappeared. The model card approach helps us know what questions to ask, especially to external vendors. Because if you start asking these kinds of questions to people who purport to have very reliable machines, you might find that they start saying, well, I don't know, actually, we need to get back to you on that, which is an important thing. And then I think we're going on to Trevor now.
So we've got some assessment-y stuff here. I think it's fair to say that you can't just plug in the model card into an existing framework like the social cognitive model or Kane's interpretive argument model. However, we have tried, and you can, to a certain degree, you can. For example, a lot in terms of social cognitive model, we put this stuff into the scoring validity argument. In terms of Kane, evaluation and generalizability, these two inferences are very much covered by the work that we're doing. Sorry, that was a bit technical, but the main thing to say is that what we want to do is have a clear overall framework in which to position the model card so that people know what to do with it in a wider validation or evaluation process. This is what we're interested in doing, and it's one of our next steps. Yeah, I mean, we've talked about this before. We don't know really enough about what's happening. What we've showed you, we believe, is probably as much as you can see anywhere on the market. If you look at the technical manuals, etc., it doesn't give you the data we've talked about today. And the only reason we're able to do this is because we have a very strong relationship with our tech partner, and we are presenting this data in conferences that they have organized. They see it as collaborative, and they're being really quite forward thinking in sort of showing us their representation, sharing the metadata. All of this kind of process is very positive, and it helps us to learn more. Yes, obviously, it's about a common language. I mean, a lot of you on the call will know the CFR. CFR is really most effective just because immediately you say B1 and everyone knows what B1 is. Now, if we could get to the stage where you say metric, human rate of reliability, blah, 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 bias for these groups, blah, 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 and everyone knows what this is referring to, you can compare tests. You don't need to have massive AI literacy to understand that this is good for low stakes or high stakes. Does it include my users? All these kind of things. You know, we're saying, what, a CFR for AI validation? Well, at least a common language, descriptors that will help us understand whether or not to use the tech. And yeah, I mean, again, we strongly believe that there is value in using the model cards in language testing. And we think, again, with the data we've been able to show you today, some of the insights, hopefully you agree with us. We said on our abstract that we wanted to raise questions, and hopefully we have, but we put them in a sort of concise list. So the first one, here's a big question. If you're trying to decide which one to use, auto-rated assessment to use, if it's in the classroom or if you're using a higher stakes test, are your students among the intended users of the auto-rated solution? This is, I mean, it's very difficult to answer this question, but in some ways you can break it down. You can say, for example, okay, I'm teaching, I don't know, in Jakarta. Were Indonesian kids part of the training set? If you're focusing on children, for example. These are questions to ask. You may not get an answer, but you can at least ask. Are you making reasonable decisions based on the scores from the auto-rating solution in terms of the stakes and reliability? This links very much to Damien's point, which is that, you know, how good is good? And we've talked about some high-level figures here. But I think the key thing is, if you're making life-changing decisions, then there must be greater scrutiny of the metrics, greater scrutiny of the reliability, a greater scrutiny of the bias. And also, we haven't talked about this, but if you're at LTRC this year, we have a session on it, which is looking at how you can cheat the machine. You know, all of these things become more and more important as the stakes increase, and we should expect more and more transparency at the same time. Any additional risks here? I mean, for example, we were talking about the environmental risks as well, not just the subgroups. These are questions to consider as well. And finally, you know, we've said that reliability metrics are important, but are they available? And are they appropriate? And that links to the point I was making again about stakes and reliability. And you'll be pleased to know we've got a feedback survey. We'll come to the end. Surely it's thanks first, right?
Yes, indeed.
Thank you. How are we doing for time?
We're right at the end. But if people do have questions,
yeah.
I'm not in a massive hurry, so
yeah,
we can go over a few minutes if people have some questions or things to discuss. But if we could ask you a huge favor, because we always like to know how these sessions went, what your thoughts are, how we can improve. So if you could please either scan the QR code, or I will throw this link into the chat. To everyone, boom. Yeah, if you guys could follow this link and tell us what you think, then that will be absolutely wonderful.
Yeah, just to say this is our first go at this, so you know, we need your feedback. We need to know how we can target it to make it more useful for you guys.
And I think Jonathan has just come back, just appeared.
Is he telling us to shut up?
Is he telling us?
Yes.
It's in the eyes. No, as Trevor and Will said, if you do have any other questions, feel free to stay for a few minutes later. We'll keep the room open. I just want to say thank you, Trevor and Will, for giving our first workshop of the conference. Wonderful job. And to everybody who attended, if you're interested in how artificial intelligence impacts language assessment, join us tomorrow when we have a plenary session and a panel discussion, all based around that topic. Trevor and Will asked for feedback separately. If you could leave us, the conference organisers, some feedback. We have 2 little questions on the platform. If you look, there's a little survey tab, 2 very simple questions. If you could fill them out, I'd be very happy and gracious. Thank you. And yeah, thank you for attending. I hope to see all of you tomorrow at the conference. Goodbye.
Thanks very much, Jonathan. Yeah, so
we're muted.
Are we muted?
No, we're not.
No, we're not.
You're not muted.
Yeah. Yeah, so just go. I think we've written down some questions, and then we'll cover a few questions here.
We covered them.
We'll go for another 5 minutes, and then if anyone wants to, I see that all the participants are still here, so that's a good sign.
That is a good sign.
That's a good sign.
Have you got nothing better to do?
So yeah, Damien asked about is it a good idea to figure out subgroups in advance?
Yes, absolutely. Yeah. That's absolutely key. I mean, it's the same principle as doing everything a priori.
Yeah.
You define them first, and then you can work on achieving fairness amongst those subgroups. It's a matter of cost. The more subgroups you have, the more expensive it is, and the less likely you're going to get such, should we say, convincing data.
Yeah.
But the more you do this, then arguably the better argument you will be able to make, and that argument might be that you shouldn't be using it for this group.
Yeah.
But yes, very good point, Damien. And we don't believe this happens enough.
Or that you shouldn't be using certain subgroups if the subgroups are problematic. But it's really important to be aware of the decisions that you're making about the groupings, why you're making those decisions, and then constantly reviewing them to make sure that they are good ones.
Feels like there are analogies between the need for increased transparency and the equivalent recent demands for there we go. Yeah, absolutely. I mean, Ricky, you've nailed it.
Yeah,
nothing more to say on that.
Yeah,
absolutely.
It would be really good if all of Facebook, Twitter, etc. had a model card that showed you how the data that you're looking at was constructed, but I don't think you'll ever get it, unfortunately.
No. But I mean, accountability is interesting. I went to a conference on AI in education a couple of years ago, actually, and even then they were saying, in terms of legal requirements, this is going to be the future. Yeah. So, watch this space, because people realize that information is power, but also with power comes great responsibility.
Yes, very good. Thank you, Spider-Man.
Yeah.
Does this automated scoring system include constructed responses or pre-fed ones, as in ELSA speaking?
I have come across ELSA Speak, and from my memory, the difference with ELSA Speak is that it doesn't measure the full construct. So what that means is that it will measure some superficial features of pronunciation, some subskills, but it won't measure, for example, what we call task engagement or fulfillment, which is what we are measuring in what do you call it? Smart learning. I should know that. There's more to that, though. You were talking about pre-fed ones. I mean, first thing to say is that they are what we were looking at is constructive responses. They're all constructive responses. When you go into pre-fed, the only reason I think you can justify that is if it's a read aloud, and pre-fed is defined by the fact you're reading aloud as well. So then you've got your training and your construct are aligning. But if you're measuring constructive responses, then of course you need to be trained on constructive responses as well.
Ricky says, but I won't want to provide too much info to all of these tech giants. Yes, absolutely. Those mysterious black box algorithms. Yeah, it's quite interesting actually with the higher levels of scrutiny, and especially with GDPR. It's getting to the point now where some of the really high performing black box algorithms may actually have to be used with much simpler algorithms, so that if someone does say, hang on a minute, why did I get turned down on this mortgage? You need to explain it to me. It's actually explainable. Yeah.
So what we're seeing now in the industry is that you develop both at the same time, and you're not just measuring the efficacy of the black box, you're measuring the comparison between the supervised and the unsupervised. And then you use the supervised to interpret the score. And there is already clauses in GDPR, as Will was saying, where in a high stakes decision, at the very least, you have to provide a human rated response, But if the decision has already been made, then sometimes there is a justification for the interpretability. So how was this score reached?
Yeah.
And that's impossible to do with a lot of the black box technology.
Oh, absolutely. Yeah. Interpretable by who? That's the question.
Yes,
That's the million-dollar
yes.
question.
Yes,
and that
it is.
was what would be very difficult to
Yeah.
define.
And what we're saying with the model cards is that we hope these are interpretable by a lot of people.
Yeah.
I know it's a different question, but you know, a lot of the issues here, again, neither of us are experienced data scientists. So we hope we understand this, you know, and we hope that you've taken some stuff away from this as well.
Yeah. Okay, so last question, and then we're going to have to run.
Yeah.
So this is from Raman. Can this automated scoring system be useful to rating group discussion? I would say no. It would be difficult.
Very difficult.
Because it depends what you're measuring. If you were trying to sort of measure the overall ability of all of the different excerpts of language, yes. But if you're talking about how well they actually discuss things with each other, then it would be very difficult.
I mean, if you break it down, first of all, speech recognizers struggle when you have voices that overlap. That's the first thing. But secondly, with a discussion, is it group discussion? You're measuring skills like, for example, how does someone stop and invite someone else to speak? Like turn taking. There hasn't been high stakes tests that are confident enough in what we call interactional competence, that interaction between speakers and that construct of language. It hasn't happened at the high stakes level yet. But I tell you what, we expect it to. And it may start with avatars. So, you know, you're interacting with an avatar, but having two people interacting together, that's kind of a bit of a holy grail at the moment.
Well, especially if both of them sound almost exactly the same.
That's right. And they overlap.
So for humans, we would think, oh, actually, okay, they sound kind of similar, but I can see very subtle differences between them. But for the machine, it would be obviously much more difficult. So yeah. And I think that's us.
Yeah, thank you very much. Really, I've got to say, fantastic questions, just really amazing interaction. And you can say the same to us in our feedback survey. You can just say how amazing it was, and good fun. Put that in there as well, Adrian. Good to see you, brother.
Yes, indeed. Thank you very much, everybody.
Thanks,
it's been a pleasure.
Yeah.
Have a wonderful day, and enjoy the rest of
the conference.
Yes.
Thanks.